What's up, good people? Thank you for joining. Thank you for liking this video. Thank you for subscribing. If you're a new member, welcome to the family. My name is Percival. So in this video, you're going to be learning about trigonometry. To be specific, you're going to be learning about how to calculate the values of this expression without using a calculator, and how to simplify this expression without using a calculator, and how to find a general solution of this equation as well without using a calculator, and also how to prove an identity. So an identity is when you're proving that the left hand side is equal to the right hand side. You're going to be learning about that, and also how to actually simplify this long expression into like a single trigonometric ratio, and how to maximize and minimize your trigonometric expression, which is really interesting. So tune in. It's going to be it's a 30 mark uh, um, question 5. So check it out. So this is from November 2022, paper 2, question 5, NCS, but applicable to other syllabus as well. So let's go. So first thing first, so let's start understanding question 5. Question 5 says 5.1 says, given that square root of 13 sine x plus 3 is equal to 0, where x is between 90 degrees and 270. So you are being told, okay, that you have square root of 13 sine x plus 3, this is equal to 0, and then we are also given a very significant information here. They say x is between 90 degrees and 270. What does that really mean, right? So if I have to draw a Cartesian plane for you, so the Cartesian plane that move on your anti-clockwise direction, so there's 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, right? And then when they say x is between 90 degrees and 270, they mean that x is between it's either on the second quadra or on the third quadra. That's what that really means. So in fact, this means that x is negative, right? Because if x is negative, that means x is either on the first quadra or in second quadra. So it means that x is negative. That's the first thing that you need to understand, and it's very important to understand the statement. This means that x is negative, and also means that whatever graph that you're gonna draw, it has to be on the first quad or second quadra, or on the third quadra. So just hold on with that thought. Firstly, is trying to understand what you're being given, and that's what you always do when you are attempting these questions. Don't just jump right to the question. Try to understand what you've been given, because you're gonna get a lot of information out of that, and you need that information for you to be able to answer these questions correctly. So that's what we're doing. We even started answering questions here, to trying to figure out what is it that we are being given. And so from here, what I would do then, I'll just try to simplify this expression. So you have root 13 sine x. I'll just take the 3 put on the left, on right hand side, just become negative 3, and then I'll just divide by root 13 on both sides. So you'll be left with sine x is equal to negative 3 over root 13, right? So with this Cartesian plane, we know that cos is positive on your fourth quadrant, and we know that all the angles, or all the sine, tan, and cos are positive on the first quadrant, and we know that only sine is positive on the second quadrant, and we know that only tan is positive on the third quadrant. So we call it the cast diagram. So we know that cos is positive, all are positive, sine is positive, tan is positive on the third quadrant. So if we look at this, we're saying that our x is here, but we see that our x is negative 3, right? That's what we expected. But we also see that then our sine value, or sine, is equal to a negative value. And we see that then sine is positive here, but sine is negative here. That means we can actually write out how this right angle triangle look like. So we have right angle triangle that will look like this. right, on the third quadrile. The reason is because our sign is negative and only tan is positive on the third quadrile. So we can then write our right angle triangle and we say, okay, cool, there's the distance between here to here is -3, and the distance between, or the hypotenuse is √13. And why they say the hypotenuse √13 is because sine x is equal to opposite over hypotenuse. So opposite over hypotenuse, that's equal to sine x. So that means that if this is an angle theta, so opposite over hypotenuse, that's sine x. So that means that's not true. This is -3. So that -3 is not true. So that means we need to consider this as -3. So -3 is here. So you need to consider that as -3. So yeah, so -3 is out down there. So this is -3, opposite over hypotenuse. Okay, opposite over hypotenuse. So we don't have the x value. So you need to find the x value. You need to find this side. We do have this side, which is -3. We do have this side, which is √13. We don't have the adjacent side. Okay, so we can actually easily find the adjacent side, but what we already have with this understanding, then we can able to jump to the questions. So if you don't understand what I just did here, let me know, because this is very important. It's very important to understand this. If you don't understand, let me know. Ask the question. I'm happy to jump right through and help where I can. But yeah, so let's get into it. So 5.1.1, they now say determine the value of this expression without using a calculator. Okay, so what you need to know before we even jump into the question, right? I'm gonna give you things that you need to know, and these are every time when I'm answering a trigonometric equation, I always without fail considering these things. Okay, number one, you need to know your cast diagram. Okay, let's just zoom in. You need to know your cast diagram. You need to know that only cos is positive here, all the positive here, sine is positive here, tan is positive here. You need to know that this is 180 degrees minus theta. You need to know that this is 180 degrees plus theta. We're gonna use this information later, right? Don't worry about it. And you need to know a couple of things. You need to know, let me put this here. You need to know this, because we're going to be calculating without a calculator. So you need to know that if you have a triangle and you know that this is 45 degrees, so this is going to be 1 and 1, and this is going to be square root of 2. Again, if you have a triangle, a right angle triangle, and let me write that, right angle triangle, right, and this is 6 degrees and this is 30 degrees, and so you should know that this is a square root of 3, this is 2, this is 1. Okay, these are things that you need to remember. Let's also go to some other things that you need to remember. You need to know that if you have sine 90 degrees, okay, sine 90 degrees, where is sine 90 plus or minus theta, which is an angle, this will give you a positive theta. But if you have sine 90, cos, instead of cos 90 degrees plus theta, this is going to give you a negative sine theta. But if you have cos 90 degrees minus theta, it's going to give you a positive sine theta. These are the things that you need to know. These are the things that you need to also remember. You need to remember this as well. You need to remember that sine theta is equal to an opposite of that angle theta over hypotenuse. So look in the opposite side of the angle cos theta. You need to remember that it is adjacent over hypotenuse, and tan theta, you need to remember that is opposite over adjacent. So looking at opposite side over adjacent side. This is the revision things you need to remember, and I always do this when I'm about to write my trigonometric test. always write them down so that when I have to answer the questions, they're already there as a cheat sheet, right? What else do you need to remember? So these are the major things that you need to remember. Later on, I'm going to bring other things. I'm going to bring other things here just to in this cheat sheet just to remember. But for 5.1, you need to remember these things. Okay. So let's go back to the question again. 5.1.1. For 5.1.1, this is what it says. It says determine the value of sine 30 degrees, 360 degrees plus x. So the way you answer this question, it's not really difficult. You always answer them in the same way. You ask the same question. So I'll show you what you do. So it's 360 degrees plus x. So what you do is you ask yourself, where do you find this angle? Where is this angle? 360 degrees plus x. Is it on first quadrant, second quadrant, third quadrant, or fourth quadrant? 360 degrees, as you can see, 360 degrees is on the fourth quadrant. 360 degrees is on the fourth quadrant. Nope, 360 degrees is on the fifth quadrant. Why do I say that? Because if you zoom in here, this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, this is 360 degrees. So it keep going. So from 0, 90, 180, 270, 360, the circle is done. And then it starts again. It keeps also going. The circle keeps on going. It can also go to the third iteration. The iteration will always continue, but you can already see that it goes once 360 and then says plus theta, so it went plus an angle, right? So that's basically what's happening here. So they say plus theta, so that's basically what's happening. So we then have to figure out we need to now, by that understanding, we know that 360 plus x is on the first quadrant, or it's on the fifth quadrant, if you may say. Fifth quadrant or first quadrant, same thing, because it's a second iteration on the first quadrant. So 360 degrees plus x is here. And we know that all angles are positive. I mean, all the trig ratios are positive in the first quadrant. So you can just then write positive sign. And then what you need to do is you need to then simplify your 360, simplify this angle that's inside and make it be on the first quadrant. So what you would do is you can just minus this whole thing by 360, because what you want to do is you want to just be left with x, so that's because x is on the first quadrant, so you're going to have sine x, and that's your answer. And sine x is already calculated above there. It's -3 over 13, and you get your 2 marks. If this doesn't make sense, let me know. Feel free to ask the question. I'm happy to help. Okay. So 5.1.2, tan x. Determine the value of tan x. So you have tan x is equal to, remember tan x is equal to, tan is opposite of adjacent. So that's what you're going to be doing here. We know that it's opposite of adjacent, and we're using this triangle here. So what do we know? This is opposite over adjacent, but we don't know the adjacent side. So we need to figure out what is the adjacent side, right? So let's go back what we have here. Let's wrap that off. Let's write down the triangle that we have. The triangle that we have, it's on the third quadrant. So meaning our x is negative. That's what we know. So we know that the adjacent side is going to be a negative value. That's very, very important to understand. So this is 13 and this is -3. The opposite side is also negative because we're looking at on the third quadrant. Okay. So how do you then find the adjacent side? We use Pythagoras to find the adjacent side. So the adjacent side will be -3 squared plus the adjacent side squared is equal to square root of 13 squared. So that's a Pythagoras theorem. X squared plus y squared is equal to r squared. If you remember that, that's basically what we're doing here. And then -3 squared is 9. So we still having the adjacent side. And square root of 13 squared, that is 13. Right? Square root of 13 squared is 13. Square root of a is a. Alright, the square root of any number is that number. Okay, so and then you have adjacent side squared, so we can take that 9 and put it on the right hand side. It's become negative, so we have 13 minus 5, and 13 minus 5 is 4. So the adjacent side, so if you square this on both sides, put a square root on both sides, you're gonna have plus or minus 4. And that's a golden rule. Every time if you have x squared is equal to a value a, and then you are introducing a square root on both sides, if you do that every time, this is going to be plus or minus a. You need to remember that, and it's very important that you do remember this, because most of the students, they don't remember this, and it's very important. If you introduce a square root on both sides, don't forget to write plus or minus where there is an actual value, not a variable. X is a variable, a is a value. Square root of a plus or minus square root of a. Okay, that's what you write. So that's why we're having adjacent side is equal to plus or minus 4. And now we need to choose adjacent side if it's positive or negative, because now we know square root of 4. We definitely know square root of 4. Square root of 4 is 2, so we have plus or minus 2. Now our answer, it cannot be plus or minus 2, it has to be one value. And then our adjacent side, we know that we've been talking about this since the beginning when we're starting, that we're looking at on the third quadral, and on the third quadral x is negative, so that's why we're saying our adjacent side is gonna be negative. So instead of positive 2, our adjacent side is equal to negative 2, and that has marks, so get a mark for identifying that. Now we know that our adjacent side is negative 2, we can write that down. Our adjacent side is negative 2. Okay, our adjacent side is negative 2. I can also put it up there, negative 2. And then from here, I can just, let me drop this off. And then remember what you're looking for. You're looking for tan x, and tan x is opposite over adjacent. Okay, and what is opposite? Opposite, because you're looking at that is x. The opposite side of x is negative 3, and the adjacent side of x is negative 2. And then your tan is 3 over 2. And we expected that. We expected the tan to be positive, because tan is positive on the third quadral. If you got tan as negative, then just know that there was something wrong there. And yeah, so that's how you calculate tan, and you get your 2 marks. So you get a mark for calculating 2, and calculating 2, and get a mark for your final answer. So if there's something you didn't understand, feel free to ask the question. I'm happy to help. So let's go to 5.1.3. Now calculate cos 180 plus x. Okay, cos 180 plus x. How do we do that? 5.1.3. So you have cos 180 degrees plus x. So cos 180 degrees plus x, you ask the same question. Where do you find this angle? Is it in the first quadral, second quadral, third quadral, fourth quadral? Right. Is 180 plus x on the first, second, or third, or fourth? You see, 180 degrees plus x is on the third quadral. And then third quadral, only tan is positive. So our cos is negative. So you write cos, negative cos. Now what you're going to do is you're going to now try to take that 180 degrees and put it back into, your first quadral. Right, so we're gonna just minus it both by 180 degrees. So you have 180 degrees plus x minus 180 degrees, which is equal to negative cos x, and that's your answer. Cos 180 plus x is equal to negative cos x. And what is negative cos x? We know cos is adjacent over hypotenuse. Cos is adjacent over hypotenuse. So what is the adjacent side? The adjacent side is negative 3, and the hypotenuse side is the square root of 13. And we write that down, negative sorry, it's not negative 3, it's negative 2. So negative 2 over square root of 13. And that's your answer. And we know cos is negative on the third quadrant, so that's what we expected it to be, negative. This is very interesting. It's very intriguing as well, but this is the golden rule. This is the golden rule, the cheat sheet. Let me write that down actually. This is our cheat. We're going to add a couple of things in this cheat sheet, but these are the things that you need to know. The rest of the things really we realize that don't need to add, but yeah, so this is what you need to know. So let's go to 5.2. Determine the value of the following expression without using a calculator. Okay, let me just wrap off what we already calculated here for 5.1. We don't need this anymore. I'm gonna keep the cheat sheet, and the rest we essentially don't need it. Okay, so let's go back. Determine the value of the following expression without using a calculator. So you have cos 90 degrees plus theta. So you have 5.2. So you have cos 90 degrees plus theta, and you have sine theta minus 180 degrees, and we have 3 sine negative theta. So that's what you have, and they want you to simplify this expression. Okay, and we're going to be using what we already know, but before we go there, I'm going to introduce you a couple of things. If you have cos of a negative, right? Cos of a negative is gonna be positive cos theta, right? But if it's tan negative, it's gonna be negative tan theta. If it's sine of negative, it's gonna be negative sine theta. So only cos can take a negative value, but the rest they become positive. Only cos can take a negative value, but the rest they can't take a negative value. They just throw it outside. They just outside and becomes negative. But cos can stomach the negative side. Okay, there's one thing we need to remember here on this cheat sheet. Right, so let's then try and answer this question. So what is cos 90 degrees plus theta? Go back to the cheat sheet. 90 degrees plus theta. Voila. Cos 90 degrees plus theta is negative sine theta. So we write it down. This is negative sine theta. Cos theta minus 180. We don't know that, right? To always be having an angle plus theta or an angle minus theta. So let's just factor the negative out. So you have sine negative. If you factor the negative out, it's going to be negative theta plus 180 degrees. That's more like it. We understand that. Okay, we understand that. And negative theta plus 180, you can actually write it, instead of writing negative theta plus 180, you can write it as 180 minus theta, right? Negative theta plus 180 can be written as 180 minus theta. So let me just write that down because we are familiar with that format. That's how we're factoring out the negative. And then from here we have negative sine theta again. And remember, we said if sine is negative theta, it cannot take the negative, you just throw it outside. So that's what you're going to be doing here. So you're going to say, okay, cool, we cannot take a negative, let's just throw it outside. So negative sine 180 degrees minus theta. And then again here, sine negative theta, we cannot take the negative, so it's going to be negative 3 sine theta. Right, so we're going somewhere. So we have negative sine theta over, again, we have negative, but then we have sine 180 minus theta. And then you ask a question, where is 180 minus theta? Where is 180 minus theta? It's on the first, second, third quadrant. So we need to find that. 180 minus theta is on the second quadrant. Now, is sine positive or negative on the second quadrant? Sine is positive on the second quadrant. So we write that down. So remember, this negative comes from here. So sine is positive on the second quadrant. So write just positive sign. And then we simplify that the angle that is inside. So we simplify the angle that is inside. So it's just minus by 1/8 on both. Just minus this whole thing with 1/8. And this that can be written, and or we can have a negative sine theta. And if you minus this by 1/8, this 1/8 and this 1/8 cancel because it's 0, so you're going to be left with negative 180. So we're going to be left with negative 180. So let's we're going to be left with negative theta, because 180 minus 180, that's 0. Still, we have a negative inside. Good people, we have negative inside. So we have equal to negative sine theta over negative. And then sine cannot take the negative, so you throw it outside, becomes negative and negative, and negative become positive. Sine theta minus 3 sine theta. Now this is easy, just addition. So sine theta minus 3 sine theta is negative 2 sine theta, and you're dividing, so negative sine theta over negative 2 sine theta is equal to positive 1 over 2, because sine theta over sine theta cancels. This is 1 and this is positive, so it's become positive 1 over 2. Boom! This is very, 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 very nice. I love it. But again, I'm emphasizing the point. The point is a cheat sheet. If you understand this cheat sheet, you're good to go. You're good to go. Alright, so let's go to 5.3. So if you didn't understand what I was doing in 5.2, feel free to ask me any questions. I'm happy to answer. This is really good 5 marks, so it's easy to get these 5 marks. You just have to understand the cheat sheet that I just shared with you. So 5.3, determine the general solution of the following equation. Okay, determine the general solution of the following equation. General solution of the following equation. So I'm going to give you what you need to know with the general equation. So what you need to know with general equation is this. So if you are given, f is sine theta is equal to m, okay, this is what you have. If sine is equal to m, then the way you would calculate your theta will be equal to RA. RA is just meaning reference angle, and the reference angle in this case would be the sine inverse of m. You can punch this in the calculator, sine inverse of m. So that's your reference angle, and we always want to have your reference angle to be positive, by the way. So if it's negative, make sure you change it to be positive. And I'll show you this example. I'm going to show you how to do that. So it's going to be theta is equal to the reference angle plus 360 degrees times k, and k is an element of integers. K is an integer. So this is what you do. If it's sine, we have theta is equal to reference angle plus 360 plus times k. Or, okay, so two things. You write, this is the first general equation that you write, and the second general equation that you write, you're gonna have, it's very important, don't forget the second general equation, RA plus 360 degrees times k. That is how you do it if it's sine. Now if it's tan, okay, again, RA is cos inverse of m, a reference angle, and then if it's tan, what you do is, the way you calculate your theta will be just plus or minus RA. That's tan, plus or minus RA plus 360 degrees times k, and k is an integer. Now, did I say tan? No, that's not tan. Sorry, cos. This is cos. So that's cos, people. That's cos. In fact, I should have zoomed in long time ago because this looks too small. Now, if is tan theta is equal to m, again, you get your reference angle, and we know how to get the reference angle. Tan inverse of m. Okay. And the way you calculate your theta here is theta is equal to the reference angle plus 180 degrees times k. This is what you all need to remember. That's what you need to remember. Your reference angle is always going to be positive. If it's negative, change it to be positive. And this is what you need to. If it's sine, you put 2 general equation. If it's cos, you put 1. If it's tan, you put 1. That you need to remember. Tan is 180 degrees. Cos is 360 plus k. It's cos is plus or minus reference angle. You know, if it's sine, you need to remember it's RA and 180 minus RA. That's it different. And let's jump into 5.3. With that knowledge, we need to now to jump to 5.3. Determine the general solution of the following equation. Now we're excited because we are equipped. We know what we need to do. We're expecting certain things and we're expecting certain behavior. And we have a cheat sheet, so we're good. We're good. And nothing to worry about. And you got me as well. So we're in good hands. So let's go. Cos x plus 2 sine x. And 3 sine 2x is minus 1. Yeah, boo. Minus 1. Okay, cool. So what you would do here, number 1, you need to remember, this times this equal to 0. If you read this using English, if you multiply this and this gave you 0, that means one of these two should be equal to 0, right? Because 0 times, if this is 0 and you multiply, if it's 0 and you multiply with this equation, it should give you 0. Or if this equation is not 0 but this is 0, this should give you 0, right? Essentially what we're saying is, we're saying a times b is equal to 0. Either a is equal to 0 or b is equal to 0. That's basically what we're saying. And that's what you're going to be doing here. That's algebra for you, right? So this is going to be cos x is a plus. Yeah, okay. Plus 2 sine x is equal to 0, or 3 sine 2x minus 1 is equal to 0. Okay, one of the two is equal to 0. That's given. Okay, cool. Let's look at all this side here. Let's look at this one here. So you have cos x plus 2 sine x equal to 0. What I would do then here, I would just divide by cos on both sides. Why I'm dividing by cos on both sides is because we're going to have sine x over cos x, and that's tan x. We know that. We know that. Sine x over cos x is tan x. We know that. So this is 1 plus 2 sine x over cos x is tan x. We know that. 0 over cos is 0. Okay. And then from here, we can now take that 1, put it on the right hand side, becomes negative. So you have 2 tan x is equal to minus 1. And you can divide by 2 on both sides because you're solving for tan. So if tan x is equal to negative half. Okay. So tan x is equal to negative half. Remember the equation. The question is, determine the general solution of the following expression. Okay, so again, if we have tan, what did we say? Now we have a situation. Tan is equal to m. You need to find the reference angle first, and this is how you find the reference angle. And then you say theta plus the reference angle plus 180 degrees times k, and k is the element of integers. So that's what you're going to be doing. So first thing first, you need to find your reference angle. So the reference angle is tan inverse of negative half. And they didn't say with, oh, they say without a calculator. Oh no, they didn't say that. Woo. Without a calculator. So let's bring our calculator. Okay, so you have tan inverse. So the way you write tan inverse, you're gonna be say shift tan inverse. So it's tan inverse or arctan. Some other people call it like that, depending where you at. So tan inverse is essentially almost. Let me just. It's too big. So it's almost negative 26.57 degrees. So that's tan inverse. Approximately negative 26.57 degrees. Right. So then we said general equation. Remember, what did we say? We said it's always positive. Your RA is always positive, but we're getting RA as negative here. Getting our RA is negative, so we need to make this positive. Okay, how do we do that? How do you make this positive? That's the golden question. So again, the way you would do this, you would essentially want to make this a negative and a positive experience. So to make this a positive experience, I would essentially say, I would just say for tan to be positive, right? For tan to be positive, tan is positive on the third quadrant. And on the third quadrant, say 180 plus theta. So that's what you're going to be doing. Because tan is positive on the third quadrant, and you want to make this whole thing positive. So you're going to just say 180 plus this RA. So 180 plus the RA, and you get 153. So this still is equal to 153.43. So negative 26.57 degrees is equal to 153.43. That's your answer. I mean, you can, use it on both sides, so you see you get the same answer. So whether you say negative 26.57 or 15.3 is the same thing. But because we're looking at the reference angle always wants you to make it positive for it to work. So that's how you do it. So we said 180 plus theta, and the reason say 180 plus theta is because it's tan, and tan is positive on the third quadrant. If it was sin, we're going to just say 180 minus theta. If it was cos, we're going to say 360 minus theta. So remember that's how you make it positive. So that's why it's important. This cheat sheet is really important. It's gold. Okay, if I were you, I was going to take a screenshot of this cheat sheet or a picture of it. Okay, let's then go. Oh, I think I feel generous. I think I will write a cheat sheet and share with you on my Facebook page. If you're not on my Facebook page, please subscribe on my Facebook page and follow. I post notes in there before I post the videos. So yeah, if you don't have data, so it's good for you. Facebook is good for you. Anyways, let's go. So you have tan, and we said if you have tan, you're gonna say then theta is equal to the reference angle plus 180 times k. So that's what you're gonna be doing here. So what's the reference angle? So you have x is equal to the reference angle is 153.43 degrees plus 180 degrees times k, and k is an element of a z integer. Okay, so that's how you would do it. Now let's go for this side now. 3 is equal 3 sine 2x minus 1 is equal to 0. So what I would do here, I would essentially 2x, take that negative, put it in right hand side, become positive, divided by 3 on both sides. You have sine 2x equal to 1 over 3. Now how do you calculate the reference angle of this? Let me just put it here because I don't have space over there. So you have sine 2x is equal to 1 over 3. So how do you calculate a reference angle of this? A reference angle of this, again, we said it's an inverse. So say it's an inverse, so you have sine inverse of 1 over 3. And again, how do you calculate an inverse? You say shift sine 1 over 3. So this is almost equal to approximately 19.47 degrees. This is positive, so the reference is good. And then what do we say? We say then we have two. If it's sine, we have two general solutions. So you have this or that. So you write that down. So theta is equal to that, and remember our theta in this case is 2x. It's not just x, but it's 2x. So we write that the way it is. So we have 2x is equal to RA, and RA is 19.47 degrees plus 360 degrees times k. Or this is equal to 2x is equal to, let me just, because I'm gonna do some magic, let me put it here. 2x is equal to 180 degrees minus 19.47 degrees plus 360 degrees times k. And remember, k is an element of a z integer. That's okay, don't forget that statement. Okay, and then okay, we can even also write it here. Anyways, from here we're solving for x. We're solving a general solution of x. Okay, so what you need to do then, you need to divide by 2 throughout. So your x will be divided by 2, so it's going to be 19. So if we divide this whole thing by 2, divided by 2, so it's going to be 9.74 degrees plus 36 divided by 2 is 180 degrees times k. So that's your first general equation. And then again, you divide this whole thing by 2 as well. So you have x equal to so before you divide this, you say 180 degrees minus 19.47, and you get your 47, and you get 160.53, and divide that by 2, you get something wrong here. 160 divided by 2, and you get divided by 2. That makes sense. So that's 80 degrees 0.26 5 was 27 degrees. So that's 80.27 degrees plus 180 times k. And k is the element of a z integer. Element of z integer. So boom, 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 boom. So this is how you get your answers. That's how you get your answers. This is how you find a general solution. And I mean, you get your marks. Get your marks. So how you get a marks? You'll definitely get a mark for that. Definitely get a mark for that. Definitely get a mark for this. And doing that positive, get a mark for these two equations. And yeah, so I think this is how you get 1, 2, 3, 4, 5, 6. How many marks is this? 6 marks. Yeah, boom. That's it. So if you don't understand what I just did here, or he has like a specific question, let me know. I'm happy to help. Okay, I'm happy to help. So please ask questions. Please comment and ask questions. I am happy to help. And if this is helping you and you're getting value, smash that like button, bro. Smash it. Smash that like button. And that's how I know. Making an impact, right? Don't just watch. Just smash the like button if you like it. Just boop, 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 boop. Destroy it. 5.4. Given the identity cos x plus y times cos x minus y is equal to negative sine x squared minus sine y squared, prove the identity. Alright, so the way you would prove the identity here, I think you need to remember a couple of things before you go on. This is not part of cheat sheets. I think it's part of notes, right? It's part of your notes. It's part of something you need to know, something that you need to know by heart, essentially. You know, I don't think you need to remember this and put in your cheat sheet. I think your cheat sheet is fine like this. The rest, something that you need to know, like this is, you need to know that sine x plus cos x squared equal to 1. That you need to know. We need to know that, right? You need to know, and you need to know that you can write your sine squared x. I mean, that's just, it's algebra. Sine squared x, you can just take that cos and put it in your right hand side, becomes negative, so 1 minus cos squared x. Even with cos as well as cos squared x can be written as 1 minus sine squared x. So those are things you need to know, random things. We need to know also compound angles, right? You need to know that cos x plus y is equal to cos x cos y minus sine x sine y. You need to remember, you need to know that sine x plus y is sine x cos x cos y plus cos x sine y. Alright, these are the things you need to remember. Identity angles and compound angles. You need to remember this, okay? And that's what you're going to be using and solving 5.4.1. Prove the identity. Okay, so when you're proving the identity, what do we say? We're proving that the left hand side is equal to the right hand side, and you take one of the two and you prove. So in this case, I'll just take the left hand side, cos x plus y times cos x minus y. So let me take the left hand side, cos x plus y times, is it cos? Yes, it is cos. Cos x minus y. Okay, so this is equal to, again, what are we going to be using? This compound angle. So this is equal to cos x cos y minus sine x sine y. Doing the same thing as well. So it's going to be cos x cos y. Now it's plus instead of minus because cos x minus. It's going to be plus. Essentially, we don't need this calculator, right? Let me just take away this calculator. We have sine x sine y. Okay, and then from here, again, the left hand side is equal to what I would do then, I'll just remove the bracket. So this times that, this times that, and then this times this, and this times that. All right, so that's what you'll be doing. So cos x cos y times cos x cos y, that is cos squared x cos. I mean, we don't need to do this, really. There's something that we know from algebra that we can use. What do we know from algebra? A minus b times a plus b is equal to a squared minus b squared. That's what we know. We know that, and we're going to use that information. And you see this is a, this is minus b, a plus b. So a minus b, your answer is a minus b squared. And we're just using the rule in algebra. But you can do this, you can do that, that's fine. Multiply it throughout, and you're going to end up with this, right? Do that, and you end up with this. If you are comfortable with this, please just jump through this, because we know our algebra, we understand algebra now, right? And we want to forget the information that we already learned in our previous classes and our previous videos as well. So our answer is going to be cos squared x and cos squared x and cos squared y minus sine squared x and sine squared y. So that's our left hand side. Okay, so let's check our right hand side. How does it look like? It's 1 minus sine squared and sine. Well, so we know that if it's a 1 there and it's like cos and sine, so we're going to use this identity here. So if you look at this, it's sine and sine, so we are making everything sine. So let's change this. So cos and cos. So if cos and cos, so let's make everything sine, right? And we know the way you calculate cos squared x equal to 1 minus sine squared x. So that's what we're going to be using. So going to be 1 minus sine squared x. This is 1 minus sine squared y, sine squared x, sine squared y. So your left hand side is equal to that. And then what do? We multiply. We multiply, people. We multiply. So you're going to say 1 minus times 1 is 1. 1 times negative sine squared x is negative sine squared. Oh, that's a y, right? So this times that, okay? And then say this times this and this times that. So you're going to be left now will be negative sine squared y, x now. Negative sine squared x times negative sine squared y, that is positive sine squared x sine squared y. And this is minus sine squared x. That sounds good news. Now we see the answer, because this and this is a 0. So we left with 1 minus sine squared y minus sine squared x. And this is equal to the right hand side, ladies and gentlemen. I should have sound effect. I should have sound effect. Boo, 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 boo. Or something like that. I should have sound effects. I should have a sound effect. But this is how you will actually prove that the left hand side is equal to the right hand side. So if you don't have, if you still have a question on this one, please let me know. Please let me know how many marks you get. 4 marks. So I'll definitely gonna give you a mark for it. Let me see. Definitely gonna give you a mark for this. For this and for that. Yeah, I'll definitely give you a mark for that. Definitely give you a mark for an answer. And what else? Yeah, definitely give you a mark for discovering that, simplifying that. 4 marks. That's your 4 marks, people. 5.4.2. Now, hence determine the value of 1 minus sine squared 45 and 1 minus sine squared 15 without using a calculator. They don't know us. We already have a cheat sheet, so they don't know we don't. That's the reason why I told you that you need to always write down your cheat sheet before you start with trigonometry, and this is the reason. So this is the reason you have. Why am I whispering right now? I don't know why am I whispering. This is crazy. This is crazy. This is crazy. This is crazy. Hey. Alright, good. So we have 1 minus sine squared 45 minus sine squared 15 degrees. And they want you to determine the value of this without using a calculator. How do we do that, people? How do we do that? Okay, so you have 1 minus sine squared 45 and 1 minus sine squared 15. So the way you need to see this problem is, you need to see it in these eyes, right? So they tell you that this is equal to 1 minus sine squared 45 minus sine squared 15, meaning our x is 45 and the y is 15. So we can then rewrite and say, okay, cool, you have cos x plus y times cos x minus y, which can be written as cos x, which is 45 degrees, plus y, which is 15 degrees, still times cos of 45 degrees minus 15 degrees. Okay, so you have then so cos 45 degrees plus 15, that is cos what's that? That is tell me, people, tell me, that's 60 degrees times cos 45 minus 15, that is 30 degrees, right? So what you have here is equal to cos 60 degrees times cos 30 degrees. And on our cheat sheet, we know how to calculate cos 60 and 30. So if you go here, cos is adjacent over hypotenuse. So if you're looking at 60, the adjacent side is this one, the hypotenuse is this one. If you're looking at 30, the adjacent side of 30 is this, and the hypotenuse side of 30 is this. So cos 60 is, the adjacent side is, this is 1 over hypotenuse, so it's 1 over 2. Cos 30 is square root of 3 over 2. And it's going to be square root of 3 over 4. Boom. Okay. We're doing something, people. We're doing something. Calculating things without a calculator. Let's go. Why am I excited? 4 marks, Baba. 4 marks. No, this is 3 marks. 3 marks. But yeah, this is how you do it. In fact, maybe let's give it, we can't be giving 2 marks for that. So that's 1 mark. And there's 1 mark and there's 1 mark. Yeah. 3 marks for this. So let's go 5.5. If you didn't understand 5.4.2, let me know. I'm happy to help. Okay. So 5.5, consider the trigonometric expression. Now you have 16 sine x cos squared power 3x minus 8 sine x cos x. Now rewrite the following, that expression that you just, the long expression, is a single trigonometric ratio. How do we do that? How do we rewrite this long expression? So let me remove all of this. Oh god. Alright, so I'm gonna give you notes before we start. Some notes. I'm not including our cheat sheets, but I'm gonna include our notes because it's something you need to remember. And also, this is also given on your what you call formula sheet if you're writing your exam. Okay, so don't need to worry about this. So what you need to know is if you have sine 2x, this can be written as 2 sine x cos x, double angles, And if you have cos 2x, this can be written as 1 minus 2 sine squared x, or this can be written as 2 cos squared x minus 1. Is that so? Right, so you need to remember that, and that's what you need to know. Now, on top of what you have learned, this is what you need to know. Okay, so let's go to 5.5.1. Rewrite the following expression as a single trigonometric ratio. So let's write this long expression first. What is this? This is 16 sine x cos squared x. Now it's not even squared, it is cubed. 8 sine x cos x. Hey, see, when you see this sine x cos x, I'm like, this looks like this, right? So if you can just take the 8 out, or take the because this is 4 times 2, take the 4 out, factor it out, something's gonna happen, right? There must be. But you can factor out 4. If you factor out 4, let's just do that. Let's just do that. Okay, so this is equal to, let's factor out 4. So you factor out 4. So 4 times 4, this is 16. So it's going to be 4 sine x cos, okay, minus, this is going to be 2. Okay, and then, what do we do? What's next? And you see, there's something that you see, a common factors here. So sine is a common factor, cos is a common factor. So let's factor that out as well. I mean, why not? So let's factor that out. So you have 4, 2. So 2 is still a common factor. So if you factor that out, so it's going to be 4 times 2. That's going to be 2 sine x cos 3x minus, we can factor out common factors, right? Let's do that. Factor all the common factors, not one by one, okay, people? Because, you guys are smart. You know what I'm doing. So let's factor out all the common factors, right? So you'll be left with, so sine is a common factor, let's factor that out. Cos is a common factor, let's factor that out. So you'll be left with 2 sine, it's gone, cos squared x minus 1. Okay, we're going somewhere, and we already see that this is cos squared x, this is cos 2x. So this is 4 times, oh my god, so this is 4 2 sine 2x, 2 sine x cos x is that, so this is equal to sine 2x times cos 2x. What did they say? Rewrite the following expression as a single trigonometric ratio. Single trigonometric ratio. So, so do you see that is 4 sine 2x is almost similar as this thing here. Almost similar. It's just that it has a 4 instead of 2, So it's just that there's a multiplication of 2. So they just multiplied the whole thing by 2. So just multiply the whole thing by 2, right? So this become 4, this is 2, this is 2. So they just multiply everything by 2. So this is essentially equal to, because if you have, if you think about this, so you have sine 2x equal to 2 sine x cos x. This can be written, if you multiply everything by 2, this is gonna be so your answer is, drum roll please, 2 sine 4x. I should have sound effects. 2 sine 4x, and that's your answer. 2 sine 4x. There's a single trigonometric expression, and that's what they want. There's 1 mark. How many marks is this? 4 marks. It's a lot. Right, so 1 mark for that, 1 mark for that, 1 mark for that, and 1 mark for that. 4 marks. We're balling, people. We're balling. So 5.5 5.5.2. Almost there, people. Let me rub this off. 5.5.2. Okay, I don't want you to see my notes. So 5.5.2, for which values of x in the interval, and x is between 0 and 90 degrees. Okay, those my notes. My notes were telling us that we have 0 degrees and 90 degrees and 180 and 270. And what do we find out? To find that x is between 0 and 90 degrees, therefore x is positive. Therefore x is positive. That's what they are saying there. Now they gave you, will this expression have a minimum value? So they want you to find a point where this expression has a minimum value. This expression essentially is 16 sine x cos squared x minus 8 sine x cos squared x. This is equal to, we've already discovered this is equal to 4 sine 2x, right? That's what we know. We know that it's equal to 4. No, it's 2 sine, it's 2. How's it 2? Yes, it is 2. Yeah, it is 2 sine 4x. That's what you have. Yeah, why am I writing 4? Yeah. Excuse me. So this is 2 sine 4x. Okay. And when you're talking about trigonometry, you're talking about waves, right? For us to able to communicate like this, you can see me writing down, you can hear my voice, probably imagine how I look like, maybe you know how I look like because you got my pictures, but you can hear me. That's the point. And for us to hear each other, it's because of waves. We're using waves, sound waves, to see each other, and waves are talking about trigonometry. So trigonometry is the fundamentals of waves. So you're learning about tan is a wave. You're learning about cos is a wave. You're learning about sin is a wave. These are all waves. These are the waves that are used for telecommunication. You know, scientists and people who understand technology, they put satellite on the on top there in the sky and spread out waves so that you can able to connect using an internet and using waves, radio waves, and all of that. And those waves that we're talking about sine, cos, and tan. And those are the fundamentals. There's other complicated waves that you need to know, but these are the 3 waves that, according to the scope, that you need to know. And are essential and the fundamental waves. And when you're studying trigonometry, you're studying how to use and manipulate waves in your advantage to have an internet, to have communication that we have. And that's basically what you're learning here. So if you don't know when you're going to apply trigonometry, if you further your studies and do something related to telecommunication, or satellites, or your astronaut or whatever, this is what you're going to be doing. Mostly you'll be trying to manipulate your waves. Even doctors as well, if it becomes bigger. So if the wave becomes bigger, if it was half, this was going to be 1/2 instead of 2. Okay, so the wave becomes bigger. Now we have 2 sine x. Now if we times by 4x, if it's 4x, what you're going to do is you're going to now divide this whole thing by 4. So now you're making your wavelength smaller. Right? So you have, if I put this into perspective, you have this is 2, this is -2, and you have 90 and 4, 90 over 4. So 90 over 4, if you take your calculator, 90 over 4, that is 22.5 degrees. 180 over 4, that is 45 degrees. 270 over 4, that is 67.5 degrees. 360 over 4, there is 90 degrees. Okay, so what just happened? So if you look at this in perspective, right, we have a long wave. We had this wave, okay, where it was just 2 sine x. This way the 2 and this was -2, okay. But now what we have done is we compressed the wave, right? So we have like, instead of long wave, but we have now wave. So that's basically what happened. We just compressed the wave, and it's between 0 and 90 degrees, as they have mentioned here. Your x is between 0 and 90 degrees. It's on the first quadrant. So we've compressed the wave and make it looks like this. Now, what is the question? Again, what's the question? If you go back to the question, they say determine the values of x and x between 0 and 90 degrees where this expression is minimum, where the minimum value. So what we have found is this. So we have found that this is true, and 2 sine 4x is equal to that, and the minimum value, and this is the minimum value. This is where it is minimum. It is minimum here, right? This is where it's maximum, and it goes down to the minimum, it comes back. You know, it goes from 0, go to the minimum, comes back to the, also come from 0, way all the way to the maximum, goes down back to the minimum, and come back to 0. So that's basically what it does. 0, maximum, 0, minimum, 0. So you're just going to go back to maximum again. So that's basically how is it. So our x is minimum. It's 67.5 degrees. So that's your answer. 67.5 degrees. So to answer your question, the x value where this expression have a minimum value, it's when it is 67.5 degrees, and that's your answer, and it's 1 mark. So they want to know the answer only, and that's 1 mark, and that's how you get that answer. It's a long explanation, but it was worth it. I hope you enjoyed. I hope you enjoyed this paper as I did. I did enjoy this paper myself as well. I hope you learned a lot. I hope you understand that it's easy to get these 30 marks. But if you don't understand certain things, feel free to ask me any questions. I'm happy to help. My name is Percival Pagati. Thank you for joining. Thank you for subscribing. And thank you for sharing this content with other people and other students. And let's grow the community together. I'm creating these videos for you, only for you. So please let me know if you have any suggestions, anything just to make this better for you. Let me know, and I'm happy to change anything just for you. I'm happy to improve anything just for you, but I can only do that if you tell me what to do. And I'm happy to help. I'm happy to jump in and see where I can help. If you have questions, feel free to comment and let me know, and I'll make sure that I answer those questions. Happy studying. I'll see you on the next video. Boom!